Good afternoon, environmental science. We're going to be continuing our project today with wind turbines. And what I'm going to be doing is loading this particular project, which tells you what is due, when it's due, which is April 2nd. And what it says, you're going to be doing the following on a one-page piece of paper. You are going to design your wind turbines with the paper plates and rods, or you can use pencils that were distributed to you. I know not all of you have your packets because one was left in the classroom on our last meeting date, which was Friday, the 13th. I don't know if we're going to get back to school with the president's most recent statement that we're to stay in our homes until the 30th. So I don't know where that puts us, but rather than worry about trying to come back and getting these things tested, what I'm going to have you do is design it, take a screenshot of what you have designed, and explain why you chose to use that particular design. So these questions need to be answered in your one-page paper, and you're going to be using Calibri, which is usually the default for Word, and 12-point. So why are wind turbines designed the way they are today? How are commercial wind turbines different than residential wind turbines? What materials are they using and why? Then you're going to describe the blade, shaft, and pitch of a general wind turbine, and then you're going to talk about your own. So why did you choose to design yours in the way that you did? So you've got a variety of options open to you, and what I want to do is show you some material I found online which will be helpful for you. Is just basically, I Googled this and said, how do you make windmill out of paper plates? How do you make a windmill out of paper, and so on? And you're going to find that there's lots of different designs that you can use. But basically what you're going to do is connect those paper plates. Right now they should be, some of you have a whole plate, some of you have a half plate. You can divide those into quarters. You can divide them into smaller grouping as well. And you're going to tape those to a pencil. I think you only got one rod. You might have gotten two. And imagine that if you were going to be using that, if you were going to put that on some kind of spindle, how effectively would that turn? And, if we get back to school, we will test them. We'll use a fan, test them, see how quickly they can spin, how much electricity they'll really generate. And so we'll take a look at those. But what I'm going to do is post this project online. If I go back to this, is post this project, let you guys take a look at it, and you can start on this. Now, this is due on Friday. So what I'm going to do is open up Classroom, that this will be submitted on Friday. A lot of you guys are submitting work late. It's not going to work. If the work is late, I'm going to take 10% off every day that it's late. And that includes weekends because we are online. Some of you are just not checking in, or checking in when it's convenient for you instead of when we are structured to be online. I need to be online then, so do you. And so I'm doing the instruction piece today. I'm going to give you time to work. I will be available to answer any questions. But what you're going to submit to me is a screenshot of what you have designed. And I'll alter this a little bit, your wind turbine project, so that it's actually supporting what I'm saying to you right now. And so it'll be a screenshot of that, and then you will answer these questions in a 1 to 2 page paper explaining exactly why you chose that design and how effective you expect it to be, combined with these other questions. So good luck. I hope you have a great time working with these wind turbine projects. If you don't have the paper plates that you were given in class, use a paper plate from home. Don't use styrofoam, use paper. And I'm available online if you need me. Enjoy.